Hey, what's up guys? This is Guy here with KB Trainings. Welcome to this lesson number 1.1.13 in which we're going to talk about the network component, specifically the hub and the switch. In the last lesson, we talked about the endpoints, client and servers and so on. And today we're going to see how we connect those different endpoints. And this is for our course for the CCNA 200-301. So if you are getting ready for the CCNA, this is the course for it. And if you are not enrolled in this course, go on kbtrainings.com/CCNA. That's where you can enroll. You also have access to our forum where you can ask questions and, pretty much engage into discussions with many others that are preparing this exam, and you can get a lot of answers there. And there's no dumb questions. Here I go from zero to engineer, so feel free to ask any kind of questions. I will be there to respond, and other people in the forum will be able to respond as well. So last lesson we saw end devices, and end devices, for example, we can mention a regular PC or a computer, or we can have like a server or anything, a smartphone or anything is an endpoint because it's the end device that connects to a network. So in this example, we have three computers or three systems. We have A, B, and C. And from what I put in the middle here, you can see that A is a Windows 10, B is a Windows Server, so B is probably a server with Active Directory and so on, and C is just a Windows 10. So these computers are different systems. So if they want to communicate, we have to have a mean of communication. We have to have a medium. We can run a cable from A to B directly, and A can be talking to B, or B can be responding to A. This is one way of doing it. And if we want to get a connection between A and C, we can run a cable from A to C, or we can run a cable from C to B if they want to communicate. But the issue is that you don't have that many network interface card on a computer. We only usually just have one. So that's why we can just use one cable to connect to many devices. And that's where we need a device in the middle to connect these different systems. And one of the devices that we're going to see today is the hub. The hub sits here in the middle, and we can have different computers connected directly to the hub. So A, B, and C can connect to the hub, and they can communicate. So this way, if A wants to communicate with C, A would just send the traffic to the hub, and the hub will deliver that traffic to C, and C will respond. But the problem with the hub is that the hub is not smart. The hub resides at the layer 1 of the OSI model. So the hub deals with bits only, with signals. So it doesn't really know what's inside of the signals. So every time the hub receives a traffic here, the hub sends that traffic to all the ports on it. If the hub has 24 ports, that traffic is going to be sent to all the 24 ports, and that's bad. And you're going to see why. So if A is communicating with C, A is sending some packets here or some frames. The hub is receiving the frames and will send those frames at the same time to C and to B. And B will receive those packets or those frames even though those frames were not destined to be. And that's why the hub can be a collision domain in itself. What does that mean? So if we have, let me take a different color here. So if, for example, A is talking to B, and at the same time, C is feeling like talking to B as well, because B is the server. So everyone wants to talk to the server. So C is also going to be communicating with B at the same time. So if these two computers, A and C, are talking at the exact same time, what is going to happen? A collision. The two signals will be colliding on their way to B. And that's not good because B is not going to understand anything of that message because it's going to be a mix of the message from A and the message from C. And we're talking here about, depending on what we probably have electrical signal here. So it's going to be a mix of signal and it's not going to be understandable for B. So this is going to create a collision. because all the traffics are in the same collision domain. That's why I put collision domain here. This is something that we have to know and we have to understand. A collision domain is a segment of our network in which we might have a collision of signal or collision of frames. And in this case, in the hub, this whole thing is a collision domain because the traffic can collide. A traffic from any device can collide with any other traffic from any other device, and that's not wanted. We also have the broadcast domain. The broadcast domain is the domain in which a broadcast is distributed. And in our case, we're going to see in the next lesson, the router is the device that blocks broadcasts. But just know that if A sends a broadcast, it's going to be sent to everybody here. So this is also a broadcast domain. It's also a collision domain at the same time, because we might have a collision, we might also have a broadcast sent to everybody. There's also something that I put here that we're going to see is half duplex and full duplex. What does this mean? This is defining just the way two computers are communicating or two systems are communicating. If we connect A to C, this is a duplex already because we have two systems that are connected to each other. We're talking about half duplex if only one of the devices can talk at a time or can transmit at a time. If A can be the only device transmitting and C has to listen when A is transmitting or has to receive, we're talking about half duplex. So there's just one transmitter and one receiver. But we're talking about full duplex if both of them can be transmitting and receiving at the same time. So the traffic can be going from A to C and at the same time from C to A. This is full duplex. We're going to see this in detail when we will be seeing different type of cables and the layer 1 and everything. So yeah, half duplex and full duplex. Half duplex, just one of them is talking at the same time. If C is talking when A is talking, we're going to have a collision here. And that's why half duplex is not so good. But with the full duplex, they're talking back and forth and nothing happens. So this is just for your knowledge. So we see that a collision domain is a system or a segment of our network where we can have a collision. And if we have a hub in the middle here, all the system is going to be a single collision domain because all the ports on the hub can collide. So like all the traffics that are coming or leaving these ports can collide with each other. So we can define the hub as the physical layer device that connects different computers. So all the ports in a hub are part of a single collision domain and a single broadcast domain. And then comes the switch. The switch is a better version of a hub. The switch is a hub, but smarter. The switch doesn't only stay at the layer 1 or the physical layer. The switch also goes at the layer 2 or the data link layer. The switch reads the MAC addresses and the switch is able to send the traffic specifically to the computer or to the device to which the traffic is sent or destined. Let's go back to our first example and I'm going to explain. So if instead of having a hub, we have a switch here in the middle, this is what's going to happen. Of course, the switch, just like the hub, has links to all these different devices. And we have the port 1, port 2, port 3. And by the end of this video, I'm going to pull up Packet Tracer and we're going to see exactly all of this live with devices in Packet Tracer. So this is A, this is B, and that's C. And we know that every computer in a network has a MAC address at layer 2. So the switch will be able to know exactly what computer or what device is connected to each port by tracking the MAC addresses. The switch has what is called the MAC address table. It's just a table that matches the port and MAC addresses. So we have MAC addresses on this end. We also have the port on the other end. So here we have A, which is on port P1, B, which is on port P2, and C, which is on port P3. Knowing this, the switch does a better job because if A is communicating with C, The traffic coming on the port P1 will be directed to the port P3 directly. P2 will have no knowledge of this traffic unless it's a broadcast. So the switch knows exactly where every computer is and will send the traffic directly to that computer. So inside the switch, if C is communicating with B, the traffic will be coming out of P3 and will be sent to P2. So there is no collision here. Every traffic is redirected where it should be going. And that's why the only place we might have a collision is on this segment here. The segment going from the port 1 to the computer A, we might have a collision here if it's coming from this side and also leaving the computer on the other end. Also here on the port P3, we can have a collision here because, yeah, traffic can collide. We also can have collision in this segment here, which means that in this instance, we don't have a single collision domain. We have 3 different collision domains. Collision domain 1, collision domain 2, and collision domain 3. Every port of a switch is its own collision domain. So if the switch has 24 ports, we have 24 collision domain. If the switch has 3 ports or 8, we have 8 collision domains. But if the hub has 24 ports, all these 24 are part of the single collision domain. And we're going to do a little bit of that later on. But for now, the switch is the data link device that resides at the data link level. It sees the MAC addresses. It knows where every computer is connected. How does it know that? By tracking the MAC addresses. So when you have the MAC address coming on a port, the switch will know, oh, okay, so this computer is connected here. This is where it is. If I have a traffic that I have to send to this computer, this is where I should redirect that traffic. We also have to know that we have 2 different types of switches. We have layer 2 switches and layer 3 switches. Layer 2 switches are just like normal switches. I mean, I can't say normal because layer 3 are still normal, but layer 2 switches deal with layer 2 only. They only see MAC addresses. They only see layer 2 technology like the 802.1q for VLAN tagging, LLDP, LACP, or the MAC itself. It resides at layer 2, and that's what a layer 2 switch does. If you have a traffic to bring from a network to a different network, which involve routing, the layer 2 switch will not be able to do it because the layer 2 switch cannot route traffic. It just knows the local network at layer 2. But we also have layer 3 switches. These are switches that have layer 3 capabilities. They can do routing, they can do routing protocol, they can do IP, they can, they are at layer 3. They are almost like routers, but they are still different because they are switches. And usually layer 3 switches have a lot of ports, 24, 48, or even 8. But a router generally has less ports. I'm talking about enterprise routers. Of course, some other big routers in the ISP environment have way more port, but a router in general, a small enterprise or home router, has about 5 ports. So the layer 3 switch does routing and everything a router can do. So it can handle layer 2 and layer 3 at the same time. So that's all you have to know. We're going to see more of this coming up in the future. But for now, let's jump in Packet Tracer and do our topology very quickly. All right, here we have Packet Tracer. So we're going to build a quick topology with 3 computers, PC0, PC1, and PC2. First of all, let me show you quickly with the hub. I just want to show you how the hub reacts. And to do our experiment, we need to add one device, which is the sniffer. We're going to put the sniffer over here. I think I've used the sniffer once in this lesson, in this course. And you know what the sniffer does? It shows you the incoming traffic on either of the port on the sniffer. So we are going to connect our devices. We connect PC0 to the sniffer and we connect the sniffer to the hub. We also connect the hub to PC1 and we connect the hub to PC2. And I'm going to configure these different devices. So for PC1, we're going to give it, PC0, the IP will be 10.0.0.10. Same subnet mask, regular subnet mask /8. And this is the MAC address of this PC, the PC0. And we go on PC1, we configure the fast Ethernet interface with 11, and then the MAC address is, the subnet mask is the regular one, and this is the MAC address for this PC. And on PC2, we give it the IP of 10.0.0.12, regular subnet mask, and this is the MAC address. Okay, on the sniffer, the port Ethernet 1 is the one connected to the hub. This is the one we're going to be listening to. So I have the hub here, and I go on the config, on the GUI, and I make sure that I'm seeing incoming packets on the port 1. And let me clear all of this and only select ICMP, which is the protocol that handles pings. So we have only ICMP, and let me delete what I have here. So this is what I want to show you. The traffic leaving PC1 going to PC2 will be even sent to PC0, even though PC0 doesn't have anything to do with it. So if we are on PC1, let's ping PC2. So we go under the command prompt and we do ping. What is the IP of PC2? 10.0.0.12, and the pings are going. And the thing is that we can see those pings here. Why? Because this is a hub. Every traffic that is coming in the hub is sent to every port. So that's why we see this ICMP here, even though this device is not involved in the pings. So let's remove the hub and replace the hub with a switch. So I'm going to make sure I do it here. All right, so the hub is gone, and we're going to insert a switch here in the middle. And let's connect the switch to the sniffer and to all these other ports. All these other devices. Okay, and the switch is so smart that we also have things like spanning tree protocol, which is a protocol that prevents loop in our topology. So that's why you see these ports are amber now, because they are not up yet. The switch is learning to make sure it's safe to open up those ports. And when we go back to the GUI, we can delete what we have here. And let's wait for this port to come up, and we're going to do our pings. All right, so the ports are up. Let's go back in the PC2 or PC1 and do the same thing. We are pinging the PC2. You can see that we have responses here, but we don't have anything showing up because it doesn't go through the fast Ethernet 0/1 because it's not involved in this transaction. It's not involved in this communication, and that's what the switch does better. And if we are trying to ping, okay, let's go in the PC2 and ping the PC0. Then you're going to see the pings because this traffic is going to PC0. Yep, you can see the pings here. Every time you have a ping there, you also have ICMP showing on here. This is good. And then we can go on the switch and see what the switch has on it. One thing that I talked about was the MAC address table. We can see in the Cisco switch how to see the MAC address table. This command is different for different vendors. So every vendor has its way of looking at the MAC address. For the switch, I know for the Cisco, I know we haven't talked about the CLI yet, but you should be able to do this. It's a simple command. So to do that, first we need to leave this mode and go in a different mode. We type enable, and then from here we can say show MAC space address table, and when we click enter, we can see the MAC address table of this switch. So right now you see that on the port fast Ethernet 0/2 we have this computer connected to it, and on the port 0/1 we have this other computer connected to it. And yeah, this is what we exactly have in our topology here. And you will be asking yourself a question, why don't we have fast Ethernet 0/3? Because the MAC address table is wiped out if there is no traffic coming from a certain device. Like if a device doesn't communicate for a while, the entry of that device in the MAC address table is removed. And we're going to see that later on when we'll be digging deeper in the MAC address table. But if you want to get the fast Ethernet 0/3 here, what we have to do is get some traffic to it. So let's go in the port 2 and ping 10.0.0.11. So after doing this, if we go back in the switch and we do show MAC address table, you can see that we now have all the three computers listed here, and this is pretty good. All right, so that's all for today, guys, and I'm going to leave, of course, links in this lesson that you can read as much as you can, and also do a lot of labs, because that's where you learn most of what you know. So do a lot of labs in Packet Tracer. If you have GNS 3, use GNS 3, but for now, Packet Tracer does the job. And also join our forum on kbtrainings.com. And yeah, if you are not enrolled in the course, kbtrainings.com/CCNA, that's where you can get this course. And if you're watching this on YouTube, please give us a thumbs up, and don't forget to subscribe on this channel, because on KB Trainings, I'm not only trying to teach you technical things, I'm also going to be into soft skills, into interviews, how to search for a job, how to be efficient at your job interview, and so on. So if you want to stay around, subscribe to this channel and like our videos. That'll be very appreciated. Thank you for watching, and I'll see you in the next lesson. Bye.